Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. And tonight we have another algebra problem. And it's in the section that I read, pulled this problem out of a book, but it was titled Modeling Real Life. And they gave you the equation. They said the total cost, C, it's in dollars, to join a ski club is given by C equals 85x plus 60. And X is the number of trips. They want you to solve for X and determine how many trips you took if you spent $315. Now, I don't know about you, but I used to build mathematical models. I modeled real life. No one gave me the equation. Nobody. You had to develop that equation. Now we're going to go through and answer this one, but then I'm going to give you some raw data so that we can actually model real life. Okay? All right, bear with me for just a minute. This is going to be really cool. It may take a little while, but don't leave. We're going to do a linear regression model. It's the simplest of the models, okay? All right, so in this case, another challenge I have, C equals 85x plus 60. How do you know all of this, the units are correct? Well, C is in dollars. I've got dollars equals $85 per trip. But they don't tell you that. Time X trips. They do tell you that X is trips. Plus $60. Now then, if I knew the number of trips times this, the trips cancel, and I end up with just dollars. So that allows me to add everything together. Get the units in there, okay? Now then, they want to solve for X. Well, I have, and this was C dollars. So I have C dollars minus 60. I'm going to subtract $60 from both sides. C dollars minus $60. Okay, so that would cancel. So that's on both sides. And that equals $85 per trip times X trips. Now then, I can divide both sides by $85. Okay, $85 per trip. And all that cancels. So that ends up dividing that by $85 per trip. Now then, the units. You'll notice I have dollars per trip, dollars and dollars per trip. The units are going to invert, well, all of this will invert and multiply. So I have trip times C dollars minus $60 divided by $85. The dollars cancel. Actually, if I factor the dollars out, would be the proper way mathematically to do that. Dollars times C minus 60 divided by $85. Now then, the dollars cancel. That's the correct way to see that. So I'm left with C minus 60 over 85 trips. So that's why the units end up working out. So what was C? They spent 315. So that's 315 minus 60 divided by 85. So what is that? 255 divided by 85. 3 times 5 is 15. Carry the 1, 24, 1's 25. So they had, all right, so X, let's do this. X equals X trips equals c minus 60 divided by 85. Okay, and he took 3 trips. If he spent $315. Now then, again, modeling real life. Nowhere in real life are they going to give you that equation. I'm going to show you what they're going to give you. Hang in there. This is really cool. This is real stuff, okay? What I'm about to show you is exactly one of the methods you will use on the job to come up with what an equation is. Now, once you get the equation, you can do the things like we just did. The difficult part is getting the equation. What if you went out and you took some data, excuse me, I still have a cold, x sub I, y sub I. Now well, you'll see, x1 is 1, x2 is 2, 3, 4, 5. That's the data that we took. And y value would be 3, 7, 5, 11, 14. That's what you're going to have on the job. So you may say, well, I have y versus x. Y versus x. 1, 2, 3, 4, 5. So that's my values of x. 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This may look a little crazy, but first thing with that data would be, let me just put together a scatter diagram and see what it looks like. So when x was 1, y was 3. When x was 2, y was 7. 3, 4, 5, 6, 7. Okay. When x was 3, y was 5. 3, and it's a little bit down here. When it's 4, it's 11. 7, 8, 9, 10, 11. Okay, somewhere about there. And when it's 5, it's 14. So that's what the data would look like. Now, there's regression analysis that you could perform, or best fit line, if you will. Now, I could put a line about right through here, pretty close. The goal is to get a line that's fit in there such that the area under the curve, the arrow on one side is about the same as the arrow on the other side. And that's not too bad. I did pretty good there. So that line is a pretty good representation of the equation. Now, you've studied probably that y equals mx plus b. Well, how do I take that and get the y-intercept and the slope? Now, there's different ways you can do this. You know that m is the slope, and it's the change in y over change in x. And b equals the y-intercept. That's when x equals 0. So that's the equation for the line. You've already studied that. But when you're performing a regression, there's another set of calculations that you can do to come up with getting the equation of the line. I'm going to put them right here, I think. M, the slope, it equals the sum, and that would be from I equals 1 to n. So we have n is 5. I have 5 data. Okay, so x sub I minus x bar times y sub I minus y bar divided by the summation of x sub I minus x bar squared. And then the y-intercept, b, equals y bar minus m x bar. Now, you may or may not be familiar with X bar and Y bar, but all that is the average. So the average of X would be the sum of X sub I. This is X bar equals the sum of X sub I divided by N. So if I sum these up, 2 plus 1 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. So I have 15 divided by, I have N was 5, so 15 divided by 5 equals 3. So X bar equals 3. Okay, I tell you, I'm going to move this around a little bit. Not that you guys need to see me, I may make the video bad. Okay, now let's get Y bar. So Y bar equals the sum, and when I say sum, that's I equal 1 to N. 1, 2, 3, 4, 5. So I equal 1 to 5 of Y sub I divided by N. So if I add these up, 14, 24, 25, 30, 37, 40. So the sum of Y sub I is 40 divided by 5 equals 8. 40 divided by 5 equals 8. So Y bar equals 8. Now then, let's build a matrix with each of these items in it. For example, X sub I minus X bar. And then we're going to have X sub I minus X bar squared. And then we'll have Y sub I minus Y bar. And then X sub I minus X bar times Y sub I minus Y bar. And that should give me everything I need there. Yep, I think so. All right, let's walk through it. X sub I minus X bar. So we had X bar was 3. So I'm going to have 1 minus 3 is a negative 2. Okay, 2 minus 3 is a negative 1. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 2. Nothing big there. Now then, X sub I minus X bar squared. So negative 2 times negative 2 is 4, positive 4. Negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. Okay. Now, Y sub I minus Y bar. Y bar, remember, was 8. So now, Y sub I, 3 minus 8, it's a negative 5. 7 minus 8 is negative 1. 5 minus 8 is a negative 3. 11 minus 8 is a positive 3. 14 minus 8 is a positive 5. Now we need to take X sub I minus X bar times Y sub I. So I've got negative 2 times negative 5 is a positive 10. Negative 1 times negative 1 is 1. 0 times this is 0. 1 times 3 is 3. 2 times 5 is 10. Now, we need to sum I equal 1 to N of this times, these two that are multiplied together. So 10 plus 10 is 20, plus 4 is 24. 10, 20, 21, 22, 3, 4. 24. So the sum equals 24. All right, so now we need the X sub I minus X bar squared, the sum of that, which was this column. 4 plus 1 is 5. 4 plus 1 is 5. So that's 10. So the sum of that one equals 10. Now M equals that sum, 24, divided by this sum, which was 10, and that equals 2.4. So the slope, M, equals 2.4. All right. So far, so good. Now B, the y-intercept, is y bar minus m times x bar. So what do we have here? We have 8 minus 2.4 times x bar, which was 3. You still see that? Now I need to work that somewhere. All right, 2.4 times 3. 2.4 times 3, 12, 1, 6, 7.2. 8 minus 7.2 is 0.8. I hope I haven't missed that. I had a different answer earlier. I'll go back and check. If it's wrong, we'll redo the video. Okay. All right, so what's the two things I have? I'm going to erase some of this now. I'll tell you what, I'm going to erase this problem here. It was the one where they wanted us to model real life. That wasn't real life at all. This one's real life. Now, what do we have? We have y sub I, an estimate. That's what the little hat means. And that's mx plus b. And that y sub I estimate equals 2.4 times x, actually that's x sub I, plus b, which was 0.8. That is the equation of the line associated with that data set. The data that we had, that is modeling real life. So that is linear regression. Linear regression. Okay. That's one of many tools. Now, obviously, if we have a line drawn from this, we know 0.8 is my y-intercept, and for every unit 1 I go over, I go up 2.4, so I know it looks something like that. Now, if I plug in a value of x and y, for example, let's try this one. No extra charge for this one. We have y was 3 and x was 1. So we have 2.4 times 1 plus 0.8. So 2.4 plus 8 is 3.2. So, but the actual value was 3. So you can see we have an error of 0.2. And so there's other techniques that show goodness of fit of the model relative to the data. But again, this is linear regression. There's curvilinear. There's, cubic regressions. There's some really complicated ones out there. This was the most simple. But I wanted you to see when they said modeling real life, the problem they gave you was not real life modeling. It was the results of the model of real life. And you had to perform some analysis on it, which was okay. I just wanted you to see this. Okay. Why are we doing this? We're trying to build a better tomorrow and do that through math. Okay, keep studying. So as you work through your problems in your algebra and you grow your skills, somewhere along the way, start thinking about how do I take, what are the models for taking raw data and actually doing something with it? Because that's what you're going to need on the job. And that's what most classes don't teach you. So sorry for that. Okay, that's all for now. We'll talk to you next time. Thanks.